So hello, what you have just seen is the overview of how I did this perspective drawing on an A4 size. Okay, so currently what you're seeing here is a copy of that, which is reduced to an A5 or half the size or area of that A4 paper that I used. So what I did for the plotting was to use a formula, which is this. So this formula is derived from an architect whom I've listened to when I was in third year college. So this formula is a replication of something like a 30 to 60 degree angle of a cube. And these will translate to a sort of like percentage. So we have 100%, meaning if this is 3 meters, that would be the dimension. But in this case, in my example here, roughly about 30, and this is going to be like 60 degrees. From here, if you plot the cube, it would look something like this. So you have your horizon line, and that would be the formulation. So the formulation for this, like this side of the cube, if we take if this is the 100%, this will be 80% for the width, 80% for the depth, I mean this edge. So this is going to be 80% for this edge here in relationship. The depth measurement would be 40% of what it actually is supposed to be. So in my example, I did just that. So if my framework, so this is the framework we're talking about, I use this formulation to come up with these dimensions. Okay, so I was using a scale ruler to measure things. So this is going to be your 100%. Now, things to note, there are two constant lines which are involved here. First is the horizon line, and the other one is going to be your 100% line. So these two are always constant when you're using this formulation, when you're trying to plot a perspective with frameworks like this. Then here, the width is going to be 80%. So 80% for this rectangular framework, which is 18 meters. So I measured 80% of 18. So I'm using the same scale to measure this. Now, if you calculate, I'll show you this. If you calculate that, 18 times 0.8 would be 14.4. So when you're going to draw this is the number using the same scale, in which case I was using 1:100, and this is the measurement that I used. And also for the depth, which is 40% of 12 meters, because since it's going in 12 meters, and you would calculate that times 0.4, which is 4.8. So it's relating to the 100% line for the width and the depth. What I did also was to subdivide this into equal parts. Okay, so one of the things that you need to know how to do is to subdivide this into how square grids are in perspective. So one thing to take note, so if this is 10 meters, it has an 18 meter width. So the easiest way to subdivide this into two and get the middle or middle center of this is to draw an X from corner to corner of the face. When you have two intersecting diagonal lines, that would mean this is the center line. So that results in the center line. And now you know that these are 9 meters. So in perspective, the rules are that, if you put two objects with the same width, and then they're in perspective, this one, the closest face, would be slightly wider than this. So they're not equal, but they are equal in factual, in measurement. But in perspective drawing, they're drawn, this area, this width is drawn a bit more, less wider than this Now, okay, so one thing to take note on where you start from exactly the horizon line, and then how do you relate the ground, which is the 0, 0 coordinates. So that would be the the starting corner of this framework, is that you measure 1.5 meters from referring from the horizon line up and then to the bottom this, and then that's when you start measuring 10 meters for this framework, or the height or whatever height total that you need. And then from there, how do you calculate this? Is that you measure since this is 80% of the edge length in relationship to this, in perspective, is that from here, once you get the 40% here, draw that vertical line, and then you need to start from 80% of 1.5 meters from the horizon line. So if we calculate this, that would measure 1.5 times 0.8, and it would be 1.2 meters in your scale. So this is going to be 1.2 meters, and then from there, you measure 80% of that 10 meters, which is 8 meters in scale. So hopefully no one is confused about that. So here, if the depth is 12 meters, so you calculate 12 meters times 0.4, and then with your scale ruler, you measure 4.8 meters, which is 40% of 12 meters, and draw this vertical line from the 100% line. Okay, so this edge is 90% of the actual 100% measurement, or the height that you need. So in this case, it is 10 meters. Again, you need to start from the ground, which is 90% of 1.5 meters eye line. So this is in measurement is 1.35, because it's only 90% of the actual 100% line that you need. And then from there, from this ground, you measure 90% of 10 meters, which is 9. Then this is how you get this result. This is tapering towards a vanishing point of somewhere to VPX, vanishing point X. And this one is the result from just the positioning, transiting, drawing your lines from this point to that point, and going to somewhere off the page of this, which is vanishing point Y. Now you can extend this paper, and you can derive the vanishing point somewhere here. How do you subdivide this into equal verticals? Is you get the number of segments, or meters. In this case, I have 9, and then you take a look at your 100% line. I draw a diagonal from here, because you would imagine that this is a square in perspective. So this is that. Now you can draw out these things. All right, so you can measure each one and subdivide it into 9, which is like 1 meter per each. You can measure if you need from the ground. For example, here you measure 90% times 1 would be 0.9. So in your scale ruler, you can do that, and you start measuring these things 0.9, each 0.9, and in order for you to get that. I used to actually do that every time, but once I got used to this, I can subdivide it by I into 9 equal spaces, into 9 equal segments, and therefore I can do the horizon line of this going towards the vanishing point. And then after that, you would need to draw the diagonal line. Now, each intersection of this square, which is this, you now then draw a vertical line. So somebody would ask, but what if I just subdivide this into 9 equal parts by way of measurement? No, you can't do that because, again, for shortening, the rules of perspective here is being followed. Like, this width is actually different from this width. They are supposed to go smaller every time you try to draw these vertical segments, and then the smallest being here, something like here. So they're proportioned accordingly. So in order for you to get that accuracy, you can do this by segmenting. So it's like, really, if I want, what I did here is, okay, so if we do this in orthographic, if I want to subdivide this into 4 equal parts, first I measured where the lines are going to be, the horizon lines. I draw the horizon line, I draw a diagonal, and then where they intersect, the diagonal and the horizon line intersect, that's where I draw my vertical. So it's the same principle here when you're trying to draw it in perspective. Now here, we only have 6, so you can measure, like, you can count 1, 2, 3 until 6. And you can imagine this as your square, draw a diagonal line, and subdivide these into 6 equal parts. So I can X this, I know where this is, so I need to segment this into 3 equal parts later on. So here, and then draw the horizon line, draw the diagonal line here, and then where they intersect, that's where you subdivide your vertical lines. Spacing. Okay, so to summarize everything that I have discussed so far, establish first your horizon line and your 100% line. Measure 1.5 meters from here, from the horizon line, once you establish with your scale ruler. And then from there, you establish the height of the framework that you need, after which you determine the depth by 40% of where your line is supposed to be. Now you can extend your line, and then you measure the 80% of your width, whatever measurement that is, and then you draw only 80% of the width based on a scale. And then you determine then the base point of this edge, which is 80% of 1.5 meters, and then which is, in this case, is 1.2 meters. And then from there, from that ground zero, you measure 80% of whatever height you need here, which is then there. And then you determine next the 90% of this from the eye level of a person to the ground. That would be 90% of 1.5 meters. I measure from the horizon line to here, which is 1.35. And then from there, from ground zero here, I measure 90% of whatever height that I need. In this case is 10 meters. So 10 meters times 90% would be 9 meters for me. And then you draw out the box, the framework box. So this is tapering towards a vanishing point off somewhere off page, VPX. So this is how you get your general for any perspective drawing. So the VPY, vanishing point Y. Of course, this is the grid here looks so complicated, but what you can do also is to simplify. So when you don't need all the grids. So what you can do, I should have done also would be something like just subdivide this into the measurements, like this in be, just to know that these are the 9 and 9 meter width, and then this is going to be my 10 meters, and then halfway of this is where my 6 and 6 meters, which is 12 meters. And then if let's say I need 12 meters from here, what I can do is really just to get a third of this. How do I subdivide this into 3 equal parts? As I do that, that's halfway, which is 4.5, and do a vertical, and then I do this and I do that. So when they intersect, these things is 1/3. So 3 equal parts. If I do this, and this is where my 12 meter is, so I can write down 3 meters there. And then I can mark up these things. Okay, so this corner for where the 100% line. Okay, you can use this with your scale ruler. When you first measure, this is the 100% line, meaning it's true if you use a scale ruler to measure this, it remains the same. It's measurable. So I have my 12 meters here, my 12. So I can now plot this within a cube, the circle. So you can see the framework, the easiest framework that you could do for your design. So now you see how I've done the framework and where things are supposed to be. I want to establish the top. How did I establish the top square so that I could know how to create that circular volume? Was that to illustrate, you need to illustrate the square in perspective, the top surface of this. In order to do that, is that you get that point and then try to approximate that angle going towards the vanishing point, Y. Okay. Other cues that you can use is just guessing this. So you could see the lines are going towards there and this line going there. Now something, you could sketch it out like that. It's not going to be perfect. So once you've established the approximation of that square, you would know that this is going to be the volume for that cube, something like here. And then from there, you draw out where the midpoints are. In this case, mine's over here. So now we can draw out the tangent, the midpoint there. That's how I determined the circle here in perspective. So this example, I did not include the property line, but from these cues where I have these dimensions and then base this on my floor plan, I needed only 2 meters. So the approximation of where the property line for this edge be, that corner, that would be my property line. From here, from this corner, that would be the 2 meters. I would have a firewall, something like there, and the neighboring wall going like that. Then here, I have 5-meter frontage, roughly about 4 meters from here. So I take again from this side, 4 meters is somewhere approximate there. I want to replicate that dimension going through here, extending that. Okay, so this is slightly going to be here, and then that would be where my property line or where the sidewalk will start. And then for the corner of the lot, okay, so I have another 2 meters on this side. So I determine that by looking at here, subdivides into 3, that would be my 3. This is going to be my 2. And if I extend that proportionately, it's going to be from here somewhere. So if I do these 2, I can derive the corner, which is 3 meters, and then extending that, and that would be in the corner of my lot. If you were confused on how I explained that, because I was doing it explaining fast, you can replay this part and try to understand that. So you can see in my demonstration that I am plotting the entire structure with this framework. So it's going to take a while in creating the perspective drawing, especially if you're just beginning trying to understand this. So of course, determine where your levels are also, and then relating it. So always base your measurements from your original plan. So this is the edge, the framework of where my edge is somewhere here. And this is going a bit, this corner is going a bit by 1 meter. So I have to reflect that. So once I determine where it is, and I have to go in about 1 meter. So it's going to be somewhere there in perspective. So it's going to inwards by y-axis. This is second to the next step of final line drawing. You could use this as a way of visualizing improving the design until such case that you're satisfied with the design or the form, and then that's the only time that you do the nicer line drawing. I'll likely be doing another video of that final output of this. So you can see the development of this. I started also to place in entourage or like human figures, cars, some of the plants that are existing. So when you're trying to draw a perspective, always show, of course, where the front door is all the time. Don't draw a perspective view where you don't see the front door if you're only going to do one perspective drawing. Currently, I haven't framed this properly. It's supposed to be shifted roughly here for the focal point, 1/3 rule. But at this stage, this is still a progress of this perspective drawing, and it's also a good stage for you to sketch, design, or iterate more. In any case, you could see the entire process a bit more. That's how I arrived at this point of this perspective drawing of this structure. And I'm also thinking about some design iterations, like I want to have some slits here for light to come into these spaces more. In any case, I'll likely make another video in terms of the final line drawing of this, and then the rendering of it. Rendering meaning the shadow casting and the shading of all of this to make it a more three-dimensional illustration for this architecture design. We'll see you then in that next video. Bye.